Saxon Algebra 1/2, lesson 98. Greetings, students. We're going to talk some more about angles. We talked about angles. No, I guess it wasn't you guys. It was the Algebra 1 kids talked about angles in the last lesson. But you get them this lesson. Last time we talked about two steps. First of all, let's just talk about how we use symbols to describe angles. Here is a triangle. And we usually describe the angles or label the angles with uppercase letters, okay? When we talk about the lengths of the sides, we usually use lowercase letters, but the corners, the vertices, if you will, the angles of a triangle are usually used with uppercase. Now this angle, we call angle A. We would say that, but in symbols, we would draw a picture of a little angle and then write the A. So that's angle A. These are all ways of saying the same thing. This is a fussier version that I don't often use, but John does occasionally. The measure of angle A. Okay, so that stands for measure. These are all ways these two in math speak are ways to say angle A. Now, sometimes when a diagram, when a diagram is more complicated, and I'll draw a complicated one in a minute, sometimes we'll describe the angle in terms of points on the other side of the angle. So I might describe this angle as angle BAC, because that kind of helps you draw the picture of the angle. So I could also say this is angle BAC, right? BAC defines this angle. Or I could say CAB. All right, so there's 5 different ways we might describe that angle. So, I mean, it's not hard, but it can be a little confusing sometimes. But just remember that there's lots of ways to note the angle. Now, the more complicated picture that I wanted to draw for you would be something like this. So here what we have, and we're going to talk more about this in just a second, are two angles next to each other. That's what we call adjacent angles. That's an A, it doesn't look like one. Okay, this is a more complicated pair of angles, right? There are two angles here that are stuck together. Neither end is closed off to make a triangle, but we can see there's a lot of similarities, right? It's as if we took this and let it keep going. So we can define a lot of different angles here. We can define this a lot of different ways. We could call this angle BAX, right? BAX, or we could call it CAX, or we could call it angle BAY, or we could call it CAY. You see what I'm doing here, right? And then we could do them all going in this direction. XAB, YAB. I'm not going to write them all down, but you can see that the more letters you put on, the more different combinations you can create that still are just describing that basic angle. This diagram seems ridiculously complicated because why would you need all those letters on there? There will be diagrams that we run into where we have lots of letters, but it'll make more sense than this. This just seems so random that it almost seems dumb, right? But this was what we call a pair of adjacent angles because they come out of the same vertex, right? This picture isn't precisely perfect, but we can see that this angle and this angle are right next door to each other. Adjacent means next door, is how I always think of it. There are two special kinds of adjacent angles that we want to focus on. If we take a 90-degree angle and we split it in some way, these two angles add up to 90 degrees, right? So I'm going to call this part angle A and this part angle B. And for complementary, and it's this kind of, you spell it with two E's. It's not a compliment like, oh, you're so cute. It's a compliment like these two things go together. Complementary angles, angle A plus angle, here, let's do it like this, plus angle B, always add up to 90 degrees. That's what complementary angles means. Yay, it's really easy. But the only thing that's hard about it is that we have another pair of angles that, and we can draw, again, the where I draw this line, how big I make these two, doesn't matter. That's not the point. The point is that if they add to 90 degrees, then they're complementary. And same for this. We'll call this one C and D. And this is a straight line, right? This was 90 degrees, but this is a straight line. We call these supplementary angles. The names can be a little confusing because they're words we've heard before. Supplements are like vitamins, right? We think of them that way sometimes. It's something that you add on as a supplement. Complement, this kind of complement is like complementary colors. But the words don't really tie in directly to these ideas. So don't overthink that. Don't try and figure out why the word supplement matches this one and why the word complement matches that one. It's not that clear of a connection. So don't worry about that. Angle C plus angle D equals 180 degrees. Okay, this is a big fat puffy cloud of knowledge. You need to get this into your brain as soon as possible and remember it. The way, and this is the only problem people have with this, you guys, is that we understand one pair of angles adds up to 90, one pair adds up to 180. That's fairly easy. The hard part is which name goes with which. Complementary comes in the alphabet before supplementary, right? C comes before S, and 90 comes before 180. So the earlier number, if you will, gets the earlier letter in the alphabet, and the later letter in the alphabet goes with the later number. That's how I remember them, and it's always been one thing that's stuck in my brain pretty easily. Okay, so there we are, complementary and supplementary angles. Examples. (97.1). What are the measures of two angles? And so I have to draw the pictures. You don't necessarily have to draw the pictures in your homework, but if you ever feel like, I don't understand, just draw the picture. It'll help you so much. Okay, so what we have, this is all from the picture. I'm not making any of this up. I'm going to make it exactly the same. Put the little arrowheads on. Okay. What are the measures of, and this is the part A, it says, what is the measure of this angle? And that goes with this diagram, and you'll see in a second how I know that. I'll explain. Okay, so he wants us to look at angle ABC and figure out how much it is. Okay, first let's figure out what angle ABC is. ABC. Okay, so it's this. We need to figure out the measure of that angle. So we start, and this is my best advice to you whenever you have a problem like this where you're trying to find an unknown in a diagram. Look at the numbers because they tell you what you do know and figure out from them how to work backwards into what you want to know. Okay, so I notice this marker. That tells me that this much is 90 degrees, and it tells me that all of this is also 90 degrees. Aha! I smell, well, partly it's a supplementary angle, but I can back it down. I just need to look at this, right? This is a complementary pair of angles. So if this one is 30, then this one must be 60 degrees. Yay, that's the answer. Okay, the second one gets a second picture. And as I start drawing it, I immediately see, oh, this one is more about the supplementary angle because it's just a straight line. There's no 90 degrees like we had in that one. And what I find out is that this little part is 45. Now, the question for this one is, what is the measure of angle DEF? This problem is a little bit confusing the way John laid it out, but just notice that he wants to know about these letters, and you know that that must be in the diagram that also has the A's and the B's and the C's, right? And here he wants to know about DEF, and this, oh, I wrote the wrong letter there. DEF. So this question obviously goes with this diagram. Okay, so in this one, let me just do this. This was 90 minus 30. That's how we got that 60 degrees. In this one, we've got the whole, we know that's 180, and this much of it is 45. So it's 180 minus 45. The whole thing is 180. This much is 45. So this angle, DEF, must be 135 degrees. And that's correct. Yay. Not so bad, right? Okay, and then the last step is measuring angles, and I need to show you the book for this, so allow me to move. Okay, this is a measurement tool for, it's a tool for measuring angles, kind of like a ruler measures straight lines. This is called a protractor. Yay. It's a protractor. You can buy them at Walgreens and Rite Aid and other places. And they're made of plastic, but what John does is he just gives us one built in. Now, the way these work in real life is that there is an open circle in the plastic right there. This whole thing would be made out of plastic. They're usually kind of like a D shape where there's an opening here. But you align the vertex of the angle in that circle, and then you align the bottom angle at the 0. Notice that this is 0 and 180. I'll explain that to you in a minute, why there are two numbers at each point. We're thinking of this as 0. And then we measure up, and we see where the top line is, and we see it's halfway between 45 and 50. That means this is a 45-degree angle, okay? Now, what if we were measuring an angle that was shaped like this? Okay, that could happen. Rather than trying to flip it around, flip our protractor around or spin our page, the protractor is set up so that we can measure angles on the other side as well. Here we would line it up at this being 0, right? Notice that when we started with 0 over here, it ends up at 180. Notice how the one set of numbers is under the line. Now we're looking at the numbers over the line, and we'll start at 0. We would line up our line here, and then we would measure back, and we would see, oh, that's a 135-degree angle. So the two sets of numbers allow you to measure angles from either side, either measuring an angle that opens from the left or one that opens from the right, if that makes any sense. Usually we use them this way. So we use the bottom set of numbers. But it helps you find the complement, right? Because we find out that if it's a 45-degree angle, its complement is 135, or supplement rather, I'm sorry, I used the wrong word. Its supplement is 135, which is just what we figured out here. 45 went with 35. So this is a cool tool because it just helps you see the supplements right off the bat. Okay, you don't need to have your own protractor. I mean, you're more than welcome to buy one if you like. I'm sure Jeff Bezos has them on Amazon. But this is the way John will give you the problems, is that he will draw the protractor, he will line it up perfectly, and you just get to figure it out. Now, so for example, if we want to find angle IDH, we would use the top set of numbers, wouldn't we? We would start from the 0. The one that's lined up is 0 here, and we would see, oh, that's a what, 48 degrees? But if we wanted to find angle AOE, we would measure on the bottom set of numbers. So it would start at 0 and go up. Oh, and it's another 45 degree. Okay, so you want to make sure that the line that you're using is the bottom. You use the grid that sets that at 0 and work from there. I hope that is logical and intuitive. I hope that this lesson is fun for you. It's kind of a nice break from solving equations and swimming fish and finding surface areas, the things that we have been doing. That is the glory of these spring quarter lessons, if you will, is that a lot of them have a slightly different feel. Okay, I'm done talking now. Enjoy your homework. Thank you. Goodbye.